In this video, we are going to talk about critical path analysis. So let's first define what I mean by a critical path analysis. It is a systematic effort to identify relationships between mission-critical applications, processes, operations, and all the necessary supporting elements for the mission-critical applications. So what I mean by this is when you have a very important system in your organization, you should consider not only the system itself, but also many supporting systems making the system work. Because the security implication of those supporting systems is that if any one of those fails, the system of your primary concern could also fail. So for example, let's say your organization is running an e-commerce server for its business, and it's a mission-critical system for the organization. And some of the dependencies associated with the e-commerce server could be internet access, computer hardware, electricity, temperature control, and storage facility. So, for example, again, if the internet access is no longer available, your e-commerce server won't work. If any of your computer hardware fails, again, the server won't work. I mean, if there's no electricity, the e-commerce server won't work either. And something gets overheated because of a failing temperature control system, again, the e-commerce server won't work either. And the e-commerce server could be dependent on a storage facility, and the failure of that storage facility could also impact the e-commerce server. So the benefits of a critical path analysis includes the production of a complete picture of the interdependencies, interactions to sustain the organization, and these interdependencies and interactions give you a clue in terms of what to look for when you're trying to protect your primary system, and what else to be protected in relation to the primary system of your interest. So the bottom line here is that by doing this critical path analysis, you could come up with a list of items to secure not only your primary system of interest, but also what else to be protected in relation with your primary system of interest. And therefore, it also builds the basic security requirements of an organization. Not just an immediate set of requirements necessary for protecting your system of primary concern, but also the security requirements associated with the primary security requirements to protect your system of primary concern. There are some additional things to look for during your critical path analysis. One of the examples of such additional things to consider is completed or potential technology conversions. So the question now is then what we mean by technology conversions. So technology conversions means the tendency for various technologies, solutions, utilities, and systems to evolve and merge over time. So when you have multiple solutions solving the same problem, those solutions will eventually merge into a single solution. That's what we mean by technology convergence here. Now, let's talk about the impact of technology convergence. Before we talk about the impacts, let's try to revisit the definition of technology convergence. In this case, the very first one we talked about in the previous slide was this multiple systems performing similar or redundant tasks, somehow turning into a consolidated system. That's what we just talked about. Another possibility is one system taking over the features and abilities of another. So what is the impact, or what are the impacts of this type of technology convergence? Let's talk about the pros first. One of the pros could be improved efficiency, because instead of using multiple systems doing the same thing, now you have a single system handling the task, and therefore there are some cost savings associated with this. What about the cons? Now, since there is only one system handling the workload, definitely there is this problem of a single point of failure, and which in turn makes the system, a consolidated system, or a more vulnerable target. So here is an example of the disadvantage. By having the technology convergence, you are more vulnerable because of the fact that now you have a single point of failure. So let's say now all your communication methods, such as voice, video, fax, data traffic, is going through a single connection path. We run into that problem of single point of failure. So if there is a single act of sabotage, you end up having no communication at all. So that's really illustrating the danger of having this single system handling all these communication needs without any redundancies. So when it comes to a critical infrastructure, it's nice to have redundancy, although efficiency is another thing to consider. So going back to our discussion of critical path analysis, having security staffs participate in site and facility design considerations is really important, because it gives you a better idea of the relationship, especially the relationship between physical security and logical security. Because a lot of times these security professionals, they think about logical security in terms of computer systems and applications, but they should also be reminded, by participating in these site and facility design consideration meetings, the fact that logical security is really dependent on physical security, and they have to consider these other physical security related factors when they're considering their security or securing their system.